Good morning, everyone. Welcome back to the Precalc series. My name is Meek, and I'm going to be teaching this class way better than your teacher can by covering things in depth the easy way. Let's get right into it. Alright guys, so today we're going to be covering how we factor polynomials. Okay, now let's first understand what factoring is. Factoring is when we take something big, like let's use a number for example, and we break it into two numbers that multiply to give us that number. Like for example, 21 and 2 would be factoring the number 42. So 21 times 2 ultimately gives us our original number 42. We're going to do exactly that process, but for polynomials, okay? So the first way we're going to look at this is, let's say I'm given the polynomial 4x squared plus 2x, okay? This is a polynomial, and I'm going to try and break this into two numbers that multiply to 4x squared plus 2x. The first thing we want to do is we want to try and take out a GCF, a greatest common factor, okay? We can see that the greatest common factor in this example would be 2x, okay? Because the coefficient of both of these numbers is divisible by 2, so 2 is going to be your greatest common factor, and they both have an x. So also an x is going to be present in your greatest common factor. So if we pull a 2x out of this equation right here, what's 4x squared divided by 2x? It's going to be 2x. What's 2x divided by 2x? It's going to be 1. So you see here, we have factored 4x squared plus 2x down into this. And if we redistribute the 2x using the distributive property, we're going to get right back to where we were. Another example, 6x squared plus 3x plus 3. Greatest common factor in this case. What's it going to be? It's going to be 3. So let's pull a 3 out of our polynomial right here. We pull a 3 outside, and that leaves us with 2x squared plus x plus 1. Now, next we're going to be looking at the difference of two perfect squares method. So this method I often see represented as the dots method, but I prefer to say it by the full name, difference of two perfect squares, because it's easier for me to specify that way, abbreviated as such. Okay, so the difference of two perfect squares, as you might guess, applies when you are dealing with a polynomial, which is a difference of two perfect squares. Like for example, x squared minus 9 is an example of a difference, meaning subtraction, of two perfect squares. Okay, so the way we factor a difference of two perfect squares is we set up our two sets of parentheses like this. We say, what is the square root of the left-hand side? We put that on the left. What is the square root of the right-hand side? We put that on the right. I'm so sorry, guys. The square root of 9 is 3. You're supposed to put 3 on the right. I don't know what I was thinking here, but just keep that in mind. And then we give a plus to one guy and a minus to the other. And that is how we do the dots method. This is going to be your final answer, factoring x squared minus 9. Now, let's do another example. Let's try to use the dots method on 4x squared minus 16. What is the square root in this case? It's going to be 2x. So we're going to put 2x on both sides of our sets of parentheses. What is the square root of 16? It's going to be 4. We're going to put 4 on both parentheses. We give one a plus, we give one a minus, and we're done. This is going to be our final answer of factoring this polynomial. Now, finally, we have what is likely the most common way we factor, which is going to be by the AM method, which is short for add, multiply. Okay? And you're going to see just exactly how that plays in right now. If I'm given a polynomial, like let's say x squared plus 2x plus 1, the AM method applies here because we have a leading coefficient of 1. The AM method only applies when the number in front of our x squared is 1. Okay? So now that we have stipulated that condition, let's continue on with how exactly we do the AM method. We look at our center term right here. Okay? We look at the coefficient of our x term, and we see it's 2. What we need to do is we need to find a set of two numbers that add to this coefficient, but multiply to this coefficient right here. Okay? So basically, we need to find two numbers that add to 2, but when multiplied together give us 1. That case is going to be 1 and 1. Okay? So now that we have our set of two numbers, we are going to start with our two sets of parentheses yet again. we are going to put an x on either side, and we are going to put one of the two numbers in each of the parentheses. And first, we know that the first number is a positive one, so we're going to put a plus sign here, and the second number is a positive one. We're going to put a plus sign here. Let's try another example. X squared minus 5x minus 50. Okay? Let's use the AM method. Remember, we need to find two numbers, let's call them A and B, where when they are multiplied together, they give us this number, but when they are added together, they give us this number. They add to this term, they multiply to this term. If you spend a little minute thinking about it, you'll realize that negative 10 and 5 add to negative 5, but multiply to negative 50. So these are two numbers, negative 10 and positive 5. Okay, so we're going to take our two sets of parentheses yet again. We're going to put x at the beginning of each, and we're going to put a minus 10 in one and a plus 5 in the other. That is your polynomial expression now factored. That's your final answer. Okay? Now, last and certainly not least, you have factoring by grouping. Okay? So factoring by grouping can be done in two scenarios, and we're going to show both of them here. First off, we can have an equation like 6x squared plus x minus 15. Now, you'll know first of all that the coefficient of x squared is something apart from 1, so we cannot use the AM method here. Okay? So we need to use a different method, factoring by grouping. The way we do factoring by grouping is we take our first coefficient, 6, and we multiply it by the last coefficient, negative 15. So that is in turn going to get us negative 90. So now the next step in the grouping method is we need to find a number that adds to this coefficient and multiplies to this number. Okay? So it's kind of like we're going through the AM method all over again. So that means we need to find a set of two numbers that add to 1 and multiply to negative 90. Okay? Well, first let's start with the numbers that multiply to negative 90, because they should be consecutive numbers if they sum to 1. Okay? So that's going to leave us with a negative 9 and a positive 10 that both multiply to negative 90 and sum to 1. So now that is what we are going to put into our equation. We're going to rewrite this down here as 6x squared minus 9x plus 10x minus 15. And you'll notice that negative 9x plus 10x is exactly the same as 1x. So now we can get into the really new stuff of factoring by grouping. So now what we're going to do is we're going to take a line and we're going to divide this into two functions. So I'm going to group 6x squared minus 9x together, and I'm going to add it to 10x minus 15. Okay? Notice my equation is still exactly the same. So now what I'm going to do is I'm going to try and find a GCF of this guy and a GCF of this guy. I'm going to pull out a 3x on this side, and it's going to leave me with 3x times 2x minus 3. And I'm going to pull out my GCF on this side. I'll notice that my GCF is 5, and that leaves me with 2x minus 3. Now you know you've done this right when you have the same parenthetical expression on both sides. Okay? So we're going to bring down our plus sign. And so now I'm going to set up my two sets of parentheses yet again. In one set of parentheses, I put my coefficients, these two coefficients right here, 3x and plus 5. And in the other set of parentheses goes my previously derived parenthetical expression, 2x minus 3. And that is my final answer. I have successfully factored by grouping. Now for my final example here, we're going to look at something that is already having 4 terms. This is going to be a third degree polynomial, as we can see. So we're going to be able to factor this by grouping. The condition that we need to meet in order to factor this by grouping is if I designate these coefficients as a, b, c, and d, then a over b needs to equal c over d. Okay? So let me do that math out. 6 over 4 has to equal 24 over 16. And they both equal 3 over 2, so I am good. I can proceed by factoring by grouping. So let's do this. We'll split it in half down the middle yet again. We'll consider this side. What's the greatest common factor on the left side? That would be a 2x squared. So if I factor out a 2x squared, what am I going to be left with? I'm going to be left with a 3x minus 2. And let me consider my right side now. If I factor out a number 8, then I'm going to be left with negative 3x plus 2. Okay? Now you'll see that these aren't exactly the same yet, so I need to pull out another number. I need to divide my right side by negative 1. And if I divide it by negative 1, it means I'm pulling it out. So instead of a plus sign here, I'm going to have a minus 8. I'm going to pull out a negative from my expression, and therefore it's going to become positive 3x minus 2. Let me rewrite that number 3 so it looks better. Okay? So now I have my two things on the right looking exactly the same, so I can proceed. I'm going to set up my two little parentheses right here. I'm going to put in the left side my coefficients, 2x squared minus 8, and the right side 3x minus 2. But note that we have not yet factored completely. I can still pull a greatest common factor out of this guy. So I can rewrite it as 2 times x squared minus 4 times 3x minus 2. But I still haven't factored completely. You'll notice I have a difference of two perfect squares right here. So let's continue factoring. Difference of two perfect squares. If we remember our rule, we set up our two little sets of parentheses. We put an x. What's the square root of 4? It's going to be 2. We give one a plus, we give one a minus. So now that this is the same as this, we can rewrite our final resultant as 2 times x plus 2 times x minus 2 times 3x minus 2. And that is our final answer. That is our original equation fully factored. If you guys ever need extra help, join the Discord server, but otherwise, enjoy your lives.